Welcome back, dear children. Now we will move to section C. Okay, here we are going to discuss about spherical mirrors. So in the previous sections we were discussing about plane mirrors, and the next one is about the spherical mirrors. Okay, so spherical mirror, from the name itself we can say a mirror which is a part of a sphere, or a mirror which is taken from a sphere can be called as a spherical mirror. So here I am considering a glass sphere. Now I am just cutting a portion from this side and another portion from this side. Okay, and here in this, so these two portions, I just cut these two portions from the sphere, this part as well as this part. Now in this one I am giving silver coating on the inner part, so it appears like this. Okay, so silver coating is given on the inner side, so this outer side will act as the reflecting side, and such a mirror is known as a convex mirror. And here this was the piece which we got from here, and in that silver coating is given on the outer part. So the inner part is the reflecting side, and such a mirror can be called as a concave mirror. Okay, so we are discussing about spherical mirrors. Mirrors which are taken from a sphere can be called as spherical mirrors. There are two types of spherical mirrors, convex mirrors as well as concave mirrors. So we are considering a sphere, and a small portion is cut from the sphere, and in that if we are giving silver coating, this is just a glass. Okay, so on one side if we give silver coating, then only it will act as a mirror. So if we are giving silver coating on the inner part and the outer bulged surface acts as the reflecting side, we will call it as a convex mirror. And if we are giving silver coating on the outer surface and if the inner surface acts as the reflecting side, we will call it as a concave mirror. Okay, so is it clear about the two different types of mirrors, convex mirror as well as concave mirror? Now we have to study certain terms related to this. Okay, so terms related to spherical mirrors. So I'll just keep this. Here I have the sphere, and from this I have taken. Okay, so this is our, which mirror is this? This is our convex mirror. Then this is our concave mirror. Okay, now next we are going to study about the different terms related to this. So the first one is center of curvature. Okay, center of curvature, and this is represented by the letter capital C. So center of curvature means it is the center of the sphere from which the mirror is taken. Okay, so what is center of curvature? It is the center of the sphere from which the mirror is taken. So here, which is the inner part? This is the inner part. In the case of a convex mirror, in the case of a concave mirror, this will be the inner part, and it is represented by C. Is it clear? So the center of the mirror, center of the sphere from which the mirror is taken is known as center of curvature. Now the second one is radius of curvature. Radius of curvature is represented by capital R. Radius of curvature is the radius of the sphere from which the mirror is taken. So what is that? So this much is the radius, isn't it? So radius of curvature is the radius of the sphere. So we discussed about two different terms, center of curvature as well as radius of curvature. Both things comes in the case of the sphere. Okay, now the next one is the pole. Pole is represented by the letter P. The geometric center of the mirror is known as a pole. Okay. The center of the sphere is center of curvature. The center of the mirror is known as the pole. Okay. So, the geometric center of the mirror, either convex or concave, can be called as pole. Now, the next one is aperture. Aperture means the reflecting side of a mirror. That is this portion. Okay. This side of the mirror can be, the reflecting side of the mirror can be called as the aperture. Now the next one is the principal axis. Okay. Principal axis is the straight line joining the pole and the center of curvature. The straight line joining the center and the pole can be called as the principal axis. So, is it clear about these terms? So, which are the terms? Center of curvature. Center of the sphere from which mirror is taken is called center of curvature. Radius of the sphere from which mirror is taken is called radius of curvature. The geometric center of the mirror is called pole. Reflecting side or the surface of the mirror is called aperture. Then principal axis is the straight line joining the pole and the center of curvature. Okay. Now we have to study about two important terms related to the mirrors. Okay. So this is very important. That is about the focus. We will call it as principal focus. So first I will be considering which type of mirror is this? This is a concave. This is a concave mirror, isn't it? So we are considering a concave mirror. Now, why did I call this as a concave mirror? For a concave mirror, the inner side is the reflecting side. Okay. Then, I have drawn the principal axis. This is the pole. Here we are having the center of curvature. Okay. So, straight line. Now, if you are drawing to the other end also, it is okay. No problem. Anyway, straight line joining center of curvature and pole is known as the principal axis. So, till this we already learned, isn't it? Now, the speciality of a concave mirror is it always converges the light rays falling on it. Okay. A concave mirror always converges. Convergence means light rays coming from different portions meet at a single point. That is known as convergence. Okay. So this concave mirror is also known as a converging mirror. It converges. That means it makes the light rays to meet at a point. So, here I am considering a light ray. How will we represent light? Light is generally represented as a ray, isn't it? Ray means a straight line with an arrowhead. So, this is a ray. A ray of light hits on this mirror. So, naturally what happens? It gets reflected. So, when we draw the ray diagrams, we have to use pencil, never draw it with a pen. And one more thing, if you simply draw the line, it won't become a ray. Ray means we need an arrow mark there. Okay. So, a ray of light which hits on this mirror after reflection passes through a point on the principal axis. So, I am considering one more light ray. So, here after hitting at this point, this also gets reflected and it moves in this direction. And what you can see is these two light rays meet at a point. And this point is called principal focus in the case of a concave mirror. Okay. So, how can you define principal focus of a concave mirror? It is the point on the principal axis where the light rays after reflection actually meets. Okay. The point on the principal axis where the light rays after reflection meets can be called as the principal focus. This is represented by the letter capital F, and this distance between focus and the pole can be called as the focal length, and focal length is represented by small letter f. Okay, so is it clear? When we are considering a concave mirror, the rays after reflection meets at a single point, and that is called principal focus, represented by capital F. Then the distance between the focus and the pole can be called as the focal length. Here, the rays after reflection actually meets together. That means it can be called as a converging mirror. Okay. Now we will move to the next type of mirror. What is this? This is a convex mirror. Here I have the pole, and in the case of a convex mirror, where is our center of curvature? It will be in the inner part, isn't it? So this is the center of curvature. Now, here I am just extending the principal axis. So we are considering a light ray which hits on the mirror. Anyway, light ray can't go and hit on the other part. This is the silvered portion. Light ray will be hitting on the aperture or the reflecting surface. So when a light ray hits on the surface, it gets reflected. Okay. Then here also when a light ray hits on the surface, it gets reflected. That means a convex mirror actually diverges the light rays. It spreads the light rays in different directions. So these rays, reflected rays actually won't meet. So what we will do is, we are extending these light rays in the backward direction. Okay. So since we are extending, I am giving dotted lines there. In the case of a convex mirror, light rays after reflection moves in different directions. Now, where we are extending the light rays in the backward direction. For all the other things, I have used dark lines, but here I have used dotted lines because the rays, these are not rays. We are extending the reflected rays in the backward direction. Then these rays meets at a point. When we are extending the light rays in the backward direction, it meets at a point, and that is called focus in the case of a convex mirror. And the distance between the pole and the focus can be called as the focal length. So how will you define principal focus for a convex mirror? The point on the principal axis from which the light rays after reflection appear to come from. Here these two are the reflected rays, and these two rays, when we look from here, it appear to come from this point. So the point from where the light rays appear to come from can be called as principal focus. Okay. So is it clear about principal focus in the case of a concave mirror as well as a convex mirror? If we are considering concave mirror, it is a converging mirror. That means the light rays after reflection actually meets at a point in the case of a concave mirror. So it is known as a converging mirror. When we are considering a convex mirror, the light rays after reflection spreads in different directions. When we extend it backward, it meets at a point. So these light rays, reflected rays, appear to come from a single point, and that point can be called as the principal focus. Now, in both the cases, the distance between the focus and the pole can be called as the focal length. So, is it clear about the terms related to what? Spherical mirrors. Okay. Now, one more term we have to consider here, that is focal plane. Okay. Focal plane means it is the plane containing the focus and the normal to it. Okay. The plane containing the principal focus and the normal to it, that region in that plane can be called as focal plane in the case of a convex mirror as well as a concave mirror. Okay, so the plane containing the principal focus and the normal to it is called focal plane. Okay, so is it clear? I need just lecture notes from this section, and you should be thorough with these terms, then only we can move to the next part. Okay, that is why I am breaking and taking the video. So in this session I just explained about the terms related to spherical mirrors, two different types of mirrors, as well as terms related to this. So once you are thorough with this, then only go to the next video. Okay, so thank you children.